Hi ladies and gentlemen, it's Mr. Green again, and I'm giving you another recording of what we're going to be doing. This is over in lesson 1. We're at the last couple of lessons it talks about describing geometry. And at the end of the lesson today, I'm going to have a guest speaker. So let's make certain we show our appreciation to that guest speaker when they get here. It'll be near the end of the lesson though, so hang on just a second. Where should you all be? Just as catching you all up, we're at lesson 15 right now, so you should be through all the quizzes through questions quiz 114. Don't forget to do those quiz corrections if you need to. They do add points to your grade, and it will help you, okay? Due dates. We go too far and they start closing. You won't be able to get back to them, so you want to make certain you're getting them done. Do not delay to get them done, okay? So what are we talking about when we're talking about describing geometry? Well, you know that in algebra we started talking about this coordinate system. We have this grid where we got the x and the y coordinate here, where this is x and this is y, right? Two-dimensional coordinates. This is quadrant 1 over here on the right, quadrant 2 over here on the left, quadrant 3 goes down here on the bottom, and quadrant 4 is this last quadrant down here, right? Knowing these quadrants is something you probably learned in algebra. And you learned that the x goes first in any ordered pair and the y comes second. And you can start at the origin and you count over to the x direction and then you count up to the y direction to locate a point. Okay? And that's the way the coordinate system works. Now, what I showed you last time, I gave you a rule and said that if we had a triangle that was located in a coordinate somewhere, and I'll just draw a triangle sitting here, just like that, and I gave you a rule. What did I say a rule was? It was something along these lines. It would say, I'm going to make a transformation of an xy coordinate, and it's going to be made in such a way, and I'm using a rule, that my t prime, my new point that I'm going to be creating, is going to be located at x plus 3 comma y minus 3. What am I saying there? That means that I'm going to take each of the points of this triangle, okay? Every single point on that triangle, and I want to transform it. That means I'm going to use the rule for it, okay? So I'm going to take point A here, and I'm going to take point B down here, and I'm going to take point C over here. I'm going to put them into that formula that I've got there. Okay? I'm trying to get my pen to start up for me here. Okay? So I'm going to say that point A is located at point negative 2 comma 5. And I'm going to use the rule. And I'm going to say, well, I'm going to add 3 on the negative 2, and I'm going to get a positive 1. So my A prime is going to be located at positive 1, comma, and y minus 3, 5 minus 3 is a 2. It's going to be located at 1, comma 2. That's going to be easy to find. All I got to do is move over 1 and up 2, and my new A prime is going to be located somewhere like that. It is simply using the rule that I'm given and the point that I'm given and relocating it. Okay? That's all that it amounts to. Now, one of the questions you might be asking is there a rule for reflection? Well, you know what? There is. If I've got a point right here, remember, reflection is the same distance away from the reflected line. So if I wanted to reflect that point over the y-axis sitting right here, well, this point is sitting at negative 3 comma 4, right? My rule for this is going to be, it's going to now be located, the new point is going to be located at 3 comma 4. I want you to notice what I did there. I took the x coordinate and I changed it from negative to positive. So the rule for this one, real easy to come up with. For reflection over y-axis. Okay? I'm going to take a point, T, x, y. Oops, that one. The new rule for this one is going to be T prime is going to be located at negative x, comma, y. That's all that there is to it. That reflected it over the y-axis. Well, what about reflecting over the x-axis? Reflection over x-axis. Does very similar. I've got a point T, x, comma, y. The rule for this one is going to be T prime will be located at x, comma, negative y. I want you to notice what I did. I simply changed the one that's not where I'm reflecting. So if I was reflecting over the y-axis, I changed the x value to a negative number. If I'm reflecting over the x-axis, I changed the y to a negative y. It simply means putting a negative sign in front of it. That's how easy it is to do those two types of reflections. Okay? Now, I promised you a guest speaker. Not much of a guest speaker. It's Mrs. Simmons. Mrs. Simmons is a teacher that's in the course, okay? She teaches this course, and if you listen and watch all the lessons, you will see her doing part of the lessons. Let's see what she's got to say for us today.
This is Mrs. Simmons, and we will write the transformation rule for the transformation of triangle ABC shown. Let's begin by choosing a point. We could select A, B, or C, but let's go ahead and start with B and its image B'. The coordinates for point B are -1, 2, and for B' are 2, -3. Next, we will determine the rule under which point B was translated to get to point B'. Let's take a look at the graph. If we look at the x-coordinates, we need to move 1, 2, 3 points to the right in order to get to B', as well as 1, 2, 3, 4, 5 units down in order to get to that point. So, to get from B, -1, 2, to B', 2, -3, we must move 3 units to the right and 5 units down. Our last step will be to write the rule that represents the transformation of all of triangle ABC onto its image. Remember, we moved 3 units to the right and down 5 units. So to write the transformation, we begin by writing x, y, arrow, and then we write x plus 3 to represent the translation to the right, and y minus 5 to represent the transformation down, and our transformation is complete.
Thank you, Mrs. Simmons. I appreciate that. Now, we're going to have our class on Thursday. Or if you have any questions about anything that comes up, make certain you're getting in touch with me. I look forward to seeing you at Class Connect, okay? Get here. Okay, if you're going to communicate with me, make certain you send me that section number so that I know who you are and I can find you quickly. It's located at the top of the course on the right-hand side, in the yellow up there at the top. Find that section number and make certain you're sending it along with any communications that you're doing. Okay? What we've been looking at is making conjectures about angles and lines and polygons. We're using the transformation to help us understand how these are happening, okay? And we're using a coordinate system and a transformation in a coordinate system to help us. And we're using 1- and 2-dimensional coordinate system to represent points, lines, and rays, line segments, and figures. We're just getting back into that coordinate system a little bit, okay? These are things that teachers want to make certain you know how to do. So, any questions? Look for them on Thursday. Bye.